Welcome to this S2 video on the cumulative distribution function. Now this follows on from what we did last time, which is the probability density function, that p.d.f. This one, the cumulative distribution function, you can think of as the c.d.f. So last time the p.d.f, this time the c.d.f. Now, why we're learning about this? Well, just like when we looked at normal distributions, if you looked at the tables, Poisson tables, binomial tables, you'll remember that they were all cumulative, because cumulative generally is something that will save us time. Now, for you to be able to tell the difference between the two, it's all about that kind of lowercase and uppercase. So our f of x, this is our p.d.f, a probability density function. The cumulative is with a capital F, so the cumulative distribution function. So our p.d.f is a small or lowercase f, and our c.d.f is a capital or uppercase f. And that's how you'll spot them when you're doing these kind of questions and you start looking at problems. Okay, it's about that little f and the capital F. Very straightforward. Now, how do we go about working this out? Well, basically, all we need to do is integrate. So our capital F of x, which is when we're looking at the cumulative, that's going to give me the probability that x is less than or equal to a value. And that we can find by integrating between that value and the lowest possible value. I'll put that as negative infinity, but it's just the lowest value you have. And a function of t dt. Now, why do we use t here? We just use another parameter because x is one of our values, one of our limits. So in that case, then we tend to use t. T is something that you see coming up quite a lot, and you'll see it in your pure mathematics as well. So if I think of this kind of graphically, whatever kind of graph I've got, say this is my graph, a value of x and the area to the left of that. That is what's going to give me my capital F of x. It's going to be this area. Nice and easy. Okay. Now, how do I go from this c.d.f back to a p.d.f? Because that is something that you're going to need to be able to do as well. Well, to do that is going to be the opposite of integrating. If we integrate f of x to get our capital F of x, so if we integrate the p.d.f to get a c.d.f, we must differentiate the c.d.f to get a p.d.f. So the easiest way, I'm just going to pop this down here. So p.d.f, c.d.f. So we integrate our p.d.f to get our c.d.f. And the reverse or the inverse of integrating is differentiating. So if I differentiate my c.d.f, I'll get back to my p.d.f. So think of that as, my f of x is the same as differentiating that c.d.f. Okay, where obviously the c.d.f is this integral here. Now, maybe I've confused you at this point, I don't know, hopefully you're okay with it, but just essentially remember that your p.d.f is finding out like a specific value in a way, and our c.d.f is finding out that kind of range of values, less than or equal to. Now, I suppose it's easier to jump into a question and do it, because there are more than one way of kind of doing this integration. I'm going to show you two ways. I'll make it clear which way is my favourite, but you go with whichever one you prefer yourself. So let's look at the first example. So here we have our random variable x as p.d.f, and here it is, a nice straightforward one. And what we've got to do is specify fully the cumulative distribution function of x, which I'll explain a little bit more as we go into it. So what I want to do is I want to integrate. So let's look at the two kind of methods. So method 1, which I'll do in black, and what that is just integrating this. So to get my capital F of x, I'm going to integrate. I'm going to integrate between x, which is like an unknown upper value at some point, and then the lower value is going to be, in this case, 1, and it is the bottom value here. So I'm integrating, rather than integrating between 1 and 3, because 1 and 3 should just give me 1, won't it? Think about it. Total area under the graph is 1. So it's 1 and some value between them. That's what I'm doing. And then what I do is I write down exactly what I see here. Instead of the x, I replace it with a t. Now, a lot of people will not replace this with a t, which isn't always fully marked wrong, but you will potentially lose a few marks for it, because it doesn't make mathematical sense to have this as an x when there's an x as one of my limits. So that's why we put t in there. So all I need to do now is integrate this. So 1/4 t, so it's going to be 1/4 t squared over 2, isn't it? Between x and 1, which that's a little bit better written as t squared over 8. Now that I've got the t squared over 8, now I can go ahead and substitute my limits in. So substituting x in gives me x squared over 8, minus, and substituting 1 in gives me 1 squared over 8, which is just 1 over 8. That then is me pretty much done. And what I need to do then is show it very much like the same way here. So when I'm going to specify this fully, I've worked out capital F of x, but I need to show it in a similar method to this. So that is shown as this, f of x. Now I've got my x squared over 8 minus 1/8, and that is between 1 and 3. Yeah, same limits. But what I also need to show is that because this is cumulative, anything that happens before 1, before this lower limit, is going to have a probability of 0. Yeah, so that will be x is less than 1. Because this is between 1 and 3, including 1 and 3, so less than 1 is going to have a probability of 0. And anything that is greater than 3 is going to have a probability of 1. Because once I get to this point, my probability is 1, isn't it? Cumulative, anything after that, it's still going to be 1. So that is now how I set this up. And you should be able to notice the difference. So you've got your capital F of x there for the c.d.f, small f of x for the p.d.f. You'll notice this will have your function within it with its limits, and 0 for everything else. So saying that the probability of anything outside of this is 0. Cumulative is a little bit different because you're totaling as you go along. So the bottom limit, anything below the bottom limit has got a probability of 0. Anything above the top limit has a probability of 1. Now, I said that there was a second method, method 2, which I'll show you now. The answer is still the same, so I'll leave that in the middle. But let's look at how we work out the second method. So the second method is when we integrate without limits. So we're just integrating our 1/4 x with respect to x. We're just integrating this, no limits. And what that will give me is x squared over 8 plus c for the constant. Okay, that's important. Now we need to find out what that constant is. And I've got two options. The easiest option is to think of my upper limit. So if I substitute 3 in, that's my upper limit. This means probability where x is less than or equal to 3, which is going to be 1, isn't it? Because it's cumulative, so the total's got to be 1. So this is going to be 1. So if I substitute 3 into here, I'm going to get, so f of 3 is simply 3 squared over 8 plus c. So 3 squared is 9. So we get 9 over 8 plus c. And of course we said that this was equal to 1, didn't we? So now you can see that c is minus 1/8, which is exactly what we got here. So you can see I'll end up with exactly the same answer, slightly different working out, probably a similar amount of time taken to do it. I do think some questions favour method 1, some questions favour method 2. What I would say is pick one method and stick with it, whichever you prefer. If you're going to keep on forgetting to put your t's in, go with method 2. Yeah? If you're happy remembering these t's, go with method 1. I would say method 1 is my favourite and is the one I'll predominantly use when we look at the examples of the answers to the questions at the end. I think I'll probably do maybe one of them with both methods, or one with one method, one with another, but most of the questions I will do with method 1. Okay, so that's part A done, that's the main bit, but part B now is just using what we've learned. So let's go back onto that. I'll pop that in red so it shows up nice and easy. You can see where I'm typing. So we're looking at when x is less than or equal to 2.5. So that means we're looking at f of 2.5. So all that means is I'm substituting 2.5 into here. So that gives me 2.5 squared over 8 minus 1 over 8. And all I need to do now is just go to my calculator. And that gives me 21 over 32. Or if you want it in decimals, 0.656 to 3 significant figures. Part C now is another one similar to this. I'll just make some room. So part C is probability when x is greater than 1.5. So that's 1 minus the probability when x is less than 1.5, which is 1 minus f of 1.5. So it's 1 minus, and all I want to do is substitute that 1.5 in. Now, I'm going to put brackets. Because of this minus sign, I don't want to make a simple sign error. Yeah, a lot of people won't put brackets here, and they may end up making a careless mistake. So we get 1.5 squared over 8 minus 1 over 8. And this is essentially what I'm talking about. Sometimes they'll put the minus here, not put the brackets, so you get minus this and minus that. Forget about the two minuses. Easy mistake to make, but it does happen. So again, you go to your calculators, nice and easy, and we get 27 over 32. Again, if you prefer in decimals, that's 0.844 to 3 significant figures. Personally, I'll leave it as a fraction unless the question specified otherwise. So that was the first one done. hopefully it makes a little bit of sense. Let's have a look at another example. Now, with this example, what you'll notice is that we have two functions within here. And again, we're going to specify that c.d.f. And I'm going to use just method 1, but remember you can use method 2, use whichever is more comfortable or what you prefer. So what we want to do is integrate both of these separately. But there is one little bit we have to be careful of, and I'll show you as we go. So looking at the first one, we're going to integrate essentially between 0, so it should just be a greater than there, 0 and 3. That's what we're integrating between. So remember, I'm using x and the lower limit 0, 1 over 6, and change my x here to a t. So integrating this, we get t squared over 2, so it's going to become t squared over 12 between x and 0. So it's going to give me x squared over 12, obviously minus the 0, or just x squared over 12. And that is my first value here. Okay. Now what I need to do is look at the next limit. Now the next limit is between my 3 and 4. Yeah. Problem with that is that this is again where a lot of students will make the mistake, because I'm doing cumulative. So although I'm going to integrate between 3 and 4, so that's between x and 3, and we get 2 minus a half t dt. But what I must remember is that it's cumulative, so I also need the total of everything that's come before it. So everything that's come before it is this integral between 0 and 3 of 1/6t dt. That's essentially it, yeah? But that's what we've done here. So this I can just replace with capital F of 3. So I'll do that in the next line so you still got it, but I would often just do it right straight here. Capital F of 3. So let's have a look. So we've got 2t minus now t squared over t, so it's t squared over 4 between x and 3 plus f of 3. So substituting in, we get 2x minus x squared over 4 minus, now substitute my 3 in, we get 6 minus 9 over 4 plus, and then again substituting 3 into this one here, the first set of values, the first function if you will. That's going to give me 3 squared, which is 9 over 12. So this is what I've got here. So we've got 2x minus x squared over 4. And then I just need to sort out my constant. And that should give me negative 3. And there we have our second value. Now this means that I can now write down what my c.d.f is. Sorry, just needed to make a little bit of room there. So my top one is going to be x squared over 12, and then my second function is 2x minus x squared over 4 minus 3. This one, sometimes you can take that fraction out. An alternative would be if I took the 4 out, then that would mean that you're effectively multiplying by 4 for each of the terms. So you'd have 8x minus x squared minus 12. And that is sometimes how it's like to be written. But I won't bother with that now. So same limits as before, 0x less than or equal to 3, and then we got 3x and 4. Remember our probabilities of 0 and 1. So this is now going to be less than or equal to 0, greater than or equal to 4. And that's simply because of my limits. This is between 0 and 3, but this one, it cannot be 3. It cannot be 0. so that's why we can go less than or equal to 0. And again, this one is not 4 because there's no equals here, so we include the 4 and above for our values. And finally, I just want to put in my little bracket, and we are done. Okay, now all we've got left now is to work out part B. So let's have a look at that. So probability when x is less than or equal to 2 just means f of 2. And when I'm doing this, I need to make sure I just look in the right limits. So 2 is here, it's in this section. So this is simply 2 squared over 12, which is 4 over 12, or 1/3. Yeah, nice and easy. I'll just tidy that up. Now, when I come to look at part C, we got less than or equal to 3.5. 3.5 is in this section, so it means we're using this one. So that means we're looking at f of 3.5, and that is simply 2 times 3.5 minus 3.5 squared over 4 minus 3. And then just to your calculator, and that gives me 15 over 16. And there I have my 2 answers. One thing to note, just as we're going along here, you'll see that often in questions I might be nipping between, say, a less than or equal to, or just a less than on its own. Okay, when I'm looking at cumulative, it makes no difference. They're both the same thing. Okay, because it's everything up to that value, is actually no numerical value, certainly in terms of the rounding we're doing. So they are in effect exactly the same thing. Now, final example. This one, you can see we've already got a c.d.f. You can see my capital F of x there, so I know it's a c.d.f. And you can see the pattern with the 0 and the 1 as well, which just confirms it. So first part, part A, is nice and easy. We're just finding the probability when x is greater than 0.3. So that's 1 minus the probability that x is less than 0.3. And that would be the same as less than or equal to 0.3. And that is just going to be 1 minus f of 0.3. We only have that one option, so it's 1 minus 2 lots of 0.3 squared minus 0.3 cubed. And of course I'm putting a big bracket around that so I don't make any sign errors. And that gives me 847 over 1000, or 0.847. Well, I'd probably write this one as a decimal, as it's a little bit nicer to write. Now let's look at part B, which is, really the main reason I'm doing this example, and that's to find a p.d.f. when I've got a c.d.f. And all I need to do, remember, is differentiate. So to find my p.d.f, I'm going to differentiate this 2x squared minus x cubed. So that's going to give me 4x minus 3x squared. And that's it. Nicely done. Just now need to set it out nicely, don't I? 4x minus 3x squared. Remember, that's then 0 on the bottom. The limit is between 0 and 1. And then this is otherwise, as all of everything outside this limit has a probability of 0. Same limits. Okay, and that's all there is to it. Now, there are a couple of examples. I think I've done 6 questions. Try to pick out questions which have a little bit of difference to them. Okay, have a little look. Any questions, fire it into the comments down below. And if you are new to my channel, please consider subscribing. Helps me out, helps you find videos, and pass it on to your friends. Okay, more people that watch the videos, the more time I'll be able to invest in them in the future, hopefully making them a little bit better.